Along the freezing coastline of northern Poland, engineers began cutting through one of the most politically sensitive stretches of land in Europe. At first glance, the Vistula Spit Canal looks surprisingly small. The canal itself is barely over 1 kilometer long. But behind this narrow waterway stood a much larger objective. Poland wanted something it had lacked for decades: independent access to the Baltic Sea without relying on Russia. Before the canal existed, ships traveling from the Polish port of Elbląg into the Baltic Sea had only one route available. Every vessel had to pass through the Baltic Strait near Kaliningrad, a maritime passage controlled by Russia. That meant a NATO member's access to its own lagoon system depended heavily on permission from another country. As tensions between Russia and Europe continued growing, that dependence became increasingly uncomfortable for Warsaw, so Poland made a dramatic decision. The government approved a $450 million engineering project to cut directly through the Vistula Spit, a narrow Baltic sand barrier stretching across the northern coastline. The objective was simple, but politically explosive. Poland wanted complete control over its own maritime access route. Construction officially began in 2019. The canal would connect the Vistula Lagoon directly to Gdansk Bay, bypassing Russian-controlled waters entirely. Even though the canal was relatively small compared to global waterways like the Panama Canal or the Suez Canal, the political symbolism behind it immediately triggered controversy across Europe. Russia strongly criticized the project from the very beginning. Environmental organizations warned about ecological damage along the Baltic coastline. European institutions demanded additional reviews, but Poland continued moving forward. For Warsaw, this was no longer simply an infrastructure project. It became a statement about sovereignty, strategic independence, and long-term regional security. What made the project especially difficult was the terrain itself. The canal route crossed unstable coastal sand formations, constantly exposed to Baltic sea waves, erosion, freezing temperatures, and shifting groundwater conditions. Engineers were not excavating through stable rock or dry land. They were attempting to permanently open a navigation channel through one of the most fragile coastal environments in northern Europe. And that was only the beginning. The excavation phase quickly transformed the coastline into one of the largest marine construction sites in Poland at the time. Massive hydraulic excavators operated continuously across the narrow sand spit, removing huge volumes of sand, mud, and sediment from the future canal alignment. Instead of discarding the material, engineers reused much of it to create artificial landforms and support infrastructure around the canal system. But excavation alone was not enough. The weak geology beneath the site created a serious long-term stability problem. Coastal sand can shift constantly under pressure from water currents and storms. Without reinforcement, the canal walls could gradually erode or collapse over time. To prevent this, engineers drove hundreds of steel piles deep into the ground along both sides of the excavation corridor. Ground stabilization became one of the most critical phases of the entire project. Construction teams used deep vibro-compaction methods to compress and strengthen the loose soil beneath the canal. Specialized equipment vibrated deep into the ground, reducing air pockets and increasing soil density so the terrain could support long-term marine operations. At the Baltic Sea entrance, engineers then began constructing the breakwater system, protecting the canal from heavy waves in winter storms. Thousands of tons of fill material were transported to the coastline to create the initial breakwater foundations. Steel sheet piles were installed to stabilize the alignment, while reinforced concrete structures locked the entire system into place. Massive concrete armor blocks were later positioned along the outer edges of the breakwaters. These specially shaped components contained openings and hollow sections designed to reduce wave pressure instead of resisting it directly. Rather than allowing Baltic waves to slam into a solid wall, the structure absorbed and dispersed the force of incoming water. This significantly improved the long-term durability of the canal entrance. At the center of the project stood the lock system, the engineering heart of the entire canal. Since water levels between the lagoon and the Baltic Sea can vary significantly during storms and seasonal changes, engineers needed a controlled system capable of regulating vessel movements safely. To construct the lock chamber, workers first created a dry work zone using double-layer steel retaining walls reinforced with giant diagonal steel braces. Once the area was isolated from surrounding water, crews
installed massive lock infrastructure inside. At both ends of the chamber, gigantic steel gates weighing hundreds of tons were connected to hydraulic operating systems capable of sealing the lock completely. Groundwater control pipes, automated valves, electronic sensors, and a centralized control center were integrated into the system to maintain stable water conditions during vessel transit. At the same time, surrounding transportation infrastructure also had to be redesigned. Since roads crossed directly over the canal route, engineers constructed rotating swing bridges capable of turning 90 degrees whenever ships approached. The automated bridge system synchronized road traffic with maritime traffic, allowing vehicles and vessels to operate efficiently within the narrow geography of the Vistula Spit. As construction continued, the canal slowly evolved from an exposed excavation site into a fully integrated maritime transport system designed to operate reliably in one of Europe's harshest coastal environments.
Technically, the Vistula Spit Canal is not among the world's largest engineering projects. It is smaller than many commercial waterways built across Europe and Asia, but its importance was never measured by length alone. For Poland, the canal fundamentally changed strategic access in the Baltic region. For the first time in modern history, Polish vessels could move directly between the Vistula Lagoon and the Baltic Sea without entering waters controlled by Russia. That single change dramatically altered the political meaning of the entire region. The canal also gained military significance almost immediately. Although Poland officially described the project as civilian infrastructure, the new route allows patrol vessels, logistics ships, and government maritime units to move independently through the lagoon system. As tensions between NATO and Russia intensified after the invasion of Ukraine, the strategic value of independent maritime access became even more obvious. Russia viewed the project very differently. Moscow argued the canal could eventually support NATO operations near Kaliningrad and criticized the growing military relevance of Baltic infrastructure projects across Eastern Europe. Environmental concerns added even more tension, with multiple organizations warning about coastal ecosystem disruption and bird habitat damage along the Baltic sand spit. Despite the criticism, Poland pushed forward until the canal officially entered operation. Today, the Vistula Spit Canal stands as far more than a transportation route. It represents a broader shift happening across Europe, where infrastructure is increasingly connected to national security, geopolitical influence, and strategic autonomy. In the end, the canal became proof that even a relatively small engineering project can reshape regional politics when geography, security, and sovereignty collide in the same location. And along the cold Baltic coastline, Poland carved out far more than a canal. It carved out an independent route to the sea.